Is the screen visible and audible, students?
Yes, sir.
Right. In the previous class, what was our topic of discussion? What was the last topic where we stopped at? The last class? Can you recollect? Yesterday's class where we stopped at? What was the last topic? Last topic of yesterday's class? Anybody? Transformation from? Yes. Cartesian to spherical, or from conversion from spherical to Cartesian. Then we have solved an example on that. Okay, fine. Today we'll be continuing with the vectors that we had started earlier. Okay, and the first topic that I'll be starting with is vector multiplication. How to multiply the given two vectors, right? Consider two vectors. Let us say there are two vectors a bar and b bar, and we want to multiply these two vectors. Now the multiplication of these two vectors a bar and b bar, it results in some answer. It results in some product, some result. Okay. Now depending upon the type of the result, there are two types of products. Depending upon the result, these two types of products are called as, first one is called scalar product or dot product, and second one is called as vector product or cross product. These topics you might have studied in your first year level. Okay, the different scalar product, dot product, or the vector product and the cross product, right? So based on the result of multiplication of the two vectors, we have two types of products. One is scalar product or dot product. Another one is vector product or the cross product. Let us see one by one what is scalar product or dot product and what is vector product or the cross product. First one, scalar product or the dot product of two vectors. When we have the two vectors a bar and b bar, the scalar product or the dot product of these two vectors a bar and b bar is denoted as a bar dot b bar. How to denote the scalar product or the dot product? The dot product of the two vectors a bar and b bar is denoted as a bar dot b bar. What is the definition then? It is defined as, scalar product or dot product is defined as the product of the magnitude of the vector A and the magnitude of the vector B and the cosine of the angle theta between the two vectors a bar and b bar. How we define scalar or dot product, students? Scalar or dot product of the given two vectors a bar and b bar is denoted as a bar dot b bar and is defined as the product of the magnitude of the vector A and the magnitude of the vector B and the cosine of the angle between the vector A and the vector B. Cosine of the angle between the vector A and the vector B. This is called as scalar product or the dot product. Okay. We'll see why it is called as scalar product. Consider this figure here. I have shown two vectors, right? Which are the two vectors here? Which are the two vectors?
A bar and B bar.
A bar and B bar. The angle between, yes, the A bar and B bar, the angle between these two vectors is angle theta. Now, if I want to find the dot product or scalar product of the two vectors A bar and B bar, what I am doing is I am taking the magnitude of this vector A multiplied with the magnitude of vector B and the cosine of this angle theta. Cosine of this angle theta between the vector A and the vector B. This is what is our scalar product or the dot product. It is magnitude of vector A into magnitude of vector B into cosine of angle theta between the vector A and the vector B, right? It can also be defined as, there is one more definition for the, that is a dot product or the scalar product. If I consider the same figure here, considering the same figure, okay. Now here, what is the projection of A bar on B bar? Can anybody tell me? Projection of A bar. You have studied in your geometry, Okay, it is your geometrical study. What is the projection of A bar on B bar? This is your projection, is it not? Where this is a dashed line is coming in contact with this bottom line, that is B bar vector. From this origin to this is our projection. Okay, or this is the line of projection. Now, how to find the projection of A bar on B bar? Your knowledge of geometry comes into picture here.
So
What
right
is the
angle
projection?
triangle.
No, it is a right angle, correct. But what is the projection? Projection of A bar on B bar. How much is the projection? Yes, please. How much is the projection? How much is the projection, students?
A bar cos theta.
A bar cos theta. How you found out that? How you found out that projection?
Cos theta, sir.
Cos theta. Very good. Cos theta is adjacent side. So we have one is A bar and then is B bar. So cos theta. I'm taking the angle cos theta. That is adjacent side divided by my hypotenuse. Correct. I want the adjacent side. That is a projection. Correct. That adjacent side is given by cos theta multiplied by A or multiplied by vector A. That is how I'm getting the projection of the vector A on the vector B. Okay. Now this vector in this scalar product or the dot product, it is also defined as the projection of the vector A on the vector B, projection of the vector A on the vector B multiplied by the vector B. Okay, it is ultimately it is the same answer, is it not? Projection of vector A on vector B is A cos theta multiplied with vector B. It is vector A into vector B into cosine of angle theta. Hence the answer is the same. It can be either defined as dot product of magnitude of A bar into magnitude of B bar into cosine of angle theta, or the projection of the vector A on the vector B bar on another vector multiplied by the another vector. That gives our scalar product or the dot product. Okay. Mathematically, it is expressed as the mathematical expression for the scalar product or the dot product is A vector dot B vector is equal to magnitude of A vector into magnitude of B vector into cosine of angle theta between A to B. Note that it is between A to B. Okay, between A to B. Take it as equation 1. Now tell me, students, what is the result of the scalar product, whether it is a vector quantity or a scalar quantity, and how?
Sir, vector quantity, sir.
Vector quantity. Any other answers? Any other answers? How it is a vector quantity? Can you justify that? How it is a vector quantity? Can you justify? Yes, please.
Sir, vector into vector, no, sir. So
Vector into vector, correct. But according to our definition, what is the formula there? A vector dot B vector is equal to formula. Think about the definition. Magnitude of vector A into magnitude of vector B into cosine of angle theta between A vector and the B vector. You have to look into the definition. Not only that, we are multiplying two vectors. Okay, it is a scalar product or dot product here, but we have to also look into the definition. Based on definition, we have to judge whether it is the answer is a scalar answer or a vector answer. Hence, what will be the answer here?
scalar quantity.
Scalar quantity, exactly. Because magnitude of vector A is a scalar quantity, magnitude of vector B is a scalar quantity, and cosine of angle theta between A to B is also a scalar quantity. So magnitude. And hence the total answer will be in terms of magnitude. It is a scalar quantity, it is not a vector. Okay, and hence we say that the dot product or the scalar product of two vectors is a scalar quantity, and hence the name given to this product is scalar product. Okay. Result of such a dot product is scalar, hence it is also called scalar product. If two vectors are parallel to each other, say here if we look into this figure, A bar and B bar, let us say they are parallel. If they are parallel, what will be the angle between these two vectors? Whether it's 0 degree or 180 degree or 90 degree, how much is the angle? Or 360 degrees? 0 degrees, exactly. If the angle between the two vectors A bar and B bar is 0, what will be their dot product? A bar dot B bar? 0, sure.
Sir, magnitude of A into magnitude of B.
Yes, magnitude of A into magnitude of B. Okay. What about the cos angle? Cos of theta is how much now?
1, sir.
Cos 0.
1.
Cos 0 is
Because
equal
the
to 1.
angle, exactly. Angle between A bar and B bar is 0. Angle between A bar and B bar is 0. Correct? Therefore, cosine of angle 0 is 1. Cos 0 is 1. Therefore, the product of A vector into B vector, that is dot product, is equal to magnitude of A vector into magnitude of B vector. That's all. Cos 0 is 1. That is what it is. That is, if two vectors are parallel to each other, theta equal to 0 degrees, then cos theta is 1. Hence, A bar dot B bar is magnitude of A into magnitude of B. Take it as second equation. Now, let us take one more the concept here. If the two vectors are perpendicular to each other, if the given two vectors are perpendicular to each other, what will be their dot product? Say these are the two vectors, A bar and B bar. 0. Now, how we came to know that it is 0?
Cos 90 is
Cos
equal to
90
0.
is 0, sir.
Cos 90, very good, very good. Cos 90 is a 0, correct. Cos 90 is a 0. If cos 90 is 0, everything, the entire product will become 0, correct. Therefore, magnitude of A into magnitude of B into cos 0, that is 0, that will cos 90, sorry, cos 90, that will become 0. Hence, we say that if the two vectors are perpendicular, then their dot product is 0, or conversely, if the dot product of two vectors, given two vectors is 0, then they are mutually perpendicular to each other. This is the concept. Similarly, for parallel vectors, if the two vectors are parallel to each other, then the dot product is the product of the magnitude of the two vectors. That is one concept. Another concept is if they are mutually perpendicular to each other, then their dot product is 0. Or if the dot product is 0, then they are mutually perpendicular to each other. Okay. Next point. If the dot product of two vectors is 0, that is, if the two vectors are perpendicular to each other, theta equal to 90 degree, cos theta is 0. Hence, A bar dot B bar equal to 0. Take it as equation 3. If dot product of two vectors is 0, the two vectors are mutually perpendicular or perpendicular to each other. Okay, these are the few points. Then one more point is whether dot product is commutative or not. Can it be commutative? Can you just give a thought on it? Commutative, is it possible with the dot product? What is commutative law in algebra? Commutative
A
law.
into B equals to B into A.
Exactly. A into B is equal to B into A. So can this law of algebra, commutative law, can it hold good for the dot product?
A bar dot B bar, sir.
B bar. Yes. Whether it
And
can be same
again
with
B
B bar
bar
dot B.
dot A bar.
Yes. Is it same? It holds good there? Yes,
Yes,
of course.
yes, sir. It holds good, sir.
It holds good. Correct. So A bar dot B bar is equal to B bar dot A bar, because A bar dot B bar is a scalar quantity. B bar dot A bar, no doubt, it is also a scalar quantity. Okay, if you take absolute value of A into absolute value of B into cosine of theta, that is also same. If you take absolute value of B into absolute value of A into cosine of angle theta, that is also same. Correct. Therefore, the A bar dot B bar is equal to B bar dot A bar. The commutative law holds good for scalar product or the dot product. Fine. Next, the dot product also obeys the distributive law. What is distributive law? A into B plus C is equal to AB plus AC. According to our law of algebra, A dot or A multiplied with B plus C into bracket, that is equal to AB plus AC. Here, A dot B vector plus C vector is equal to A vector dot B vector plus A vector dot C vector. Let us see that. It is A vector dot of b vector plus c vector is equal to a vector dot b vector plus a vector dot c vector. A vector dot c vector. Okay, that is the dot product also obeys the distributive law. If the dot product of the given vector is performed with itself, let us say we are performing the dot product of a bar with a bar, or we are performing dot product of b bar with b bar, what can be the answer? A bar dot a bar or b bar dot b bar will be what?
A bar, sir.
A bar dot a bar will be a bar. Just think of it. See, there is a bar, you are dotting it with a bar. Okay, you are performing the dot product of a bar with a bar. First, we have to think of the angle between a bar with itself. What will be the angle of the vector A with itself, or what will be the angle of vector B with itself? With itself.
Square. It's 0, sir.
0 degrees. Correct. Fine. It is 0 degrees. Hence, a vector dot a vector is equal to magnitude of a vector into magnitude of a vector into cos of 0. That is 1. That means it will be magnitude of a vector square. Absolute value of a vector square. I have written here. That is a vector. If dot product of a vector with itself is performed, the result is square of magnitude of that vector. That is a vector dot a vector is equal to magnitude of a vector into magnitude of a vector into cos 0. That will be equal to magnitude of a vector square. Take it as equation number 6. Okay. Now, here, what will be the dot product of, if you are considering, say, Cartesian system? In Cartesian system, which are the 3 coordinates? In Cartesian,
X, Y, and Z.
X, Y, and Z. Okay, I have given the example of corners of a room. Corner of a room, X direction, Y direction, and Z direction. Correct. Now, if we consider the dot product between X to Y, what it will be? Between Y to Z, what it will be? Z to X, what will be the dot product? Now, let us first consider between X to Y. X to Y. What angle between X to Y? Angle between X to Y is how much? What is the definition of the Cartesian coordinate system?
120 degrees.
No, no, no.
120.
They are mutually perpendicular. It is, don't think that the direction we have shown it like that, it is 120 degrees. No, it is not like that. It is 3-dimensional always, remember, students. So even though we have shown that as good as it is showing it as 120 degree, it is not 120 degree. It is in 3 dimension, and hence the angle is 90 degree. The direction between the 3, that is X to Y, Y to Z, and Z to X is 90 degree. Okay, they are mutually perpendicular to each other. It is in 3-dimensional. Whatever we are studying, it is in 3-dimensional. Remember, that's why I am asking you always to visualize, to imagine. Okay, they are in 90 degrees, mutually perpendicular to each other. Okay, so if it is X to Y is 90 degree, then X dot Y, that is magnitude of X into magnitude of Y into cos of 90 degree. Cos of 90 is 0. Hence, the dot product of X dot Y is 0. Dot product of X dot Y is 0. Similarly, what will be for Y to Z? X to Y we found out. What will be for Y to Z?
Same, sir. 0.
Same. Right? Is it not? So it is the same thing, because the angle is 90 degree. We get the same thing, that is 0. Z to X. Z to X.
Same, sir.
It is also same, because the angle is 90 degree. Between them, they are mutually perpendicular to each other. Hence, it is same. Is it not? So you can just think of a corner of a room. That's why I'm telling you, corner of a room. What will be the angle between them? Corner of a room. Don't think it as 120 degree. Corner of a room. Just take the 3 sides. X,
Perpendicular to each other.
90 degrees. Is it not? Their surfaces are 90 degrees with respect to each other. Yes.
Yes, sir.
And hence it is 90 degree. Don't think it as 120 degree. It is in 3-dimensional. Okay. We have found out the dot product of X to Y, Y to Z, Z to X. Now, what will be the dot product between X dot X, Y dot Y, Z dot Z? x dot x, y dot y, z dot z with itself.
X square, sir.
Yes, that is same. We'll go through that. Fine. Now, here we are considering unit vector, students. It is not the actual vectors x and y, or your a vector and b vector. They are unit vectors. Their magnitude is 1, unity. All these vectors are mutually perpendicular to each other. Hence, the dot product of different unit vectors is 0. What it means? Ax bar dot ay bar is equal to ay bar dot ax bar, or x to z or z to x. Both are same. Ax dot az bar or az bar dot ax bar, y to z or z to y. Ay bar dot az bar, or that is equal to az bar dot ay bar is equal to 0. This is 1. Okay, let us take it as equation 7. What will be the unit vector dotted with itself? Tell me, students. Unit vector dotted with itself is how much? It is a unit vector,
1,
remember?
sir.
1.
1.
Correct. Previously, what we took the point here, just go through that point. In this point, a vector dot a vector, this is a normal vector, it is not unit vector, so it is a square. But here, the magnitude of this a vector is 1 in our unit vector, in our present point, what we are analyzing there. So it is 1 square is 1 only. Hence, we say that the vector x vector dotted with itself is 1, that is x dot x is 1, ay bar dot ay bar is 1, and az bar dot az bar is 1. Unit vectors, correct? That is, any unit vector dotted with itself is unity. Ax bar dot ax bar is equal to ay bar dot ay bar is equal to az bar dot az bar is equal to 1. Is it not, friends? Take it as equation 8. Let us now consider two vectors in Cartesian coordinate system. One is vector A, that is ax bar plus ay bar. Take these two equations, students. A vector is equal to ax bar plus ay bar plus az bar. B bar is equal to bx ax bar. They are unit vectors in terms of unit vectors only, plus ay bar plus bz az bar. Take these two equations. I'll tell you all what to do next. Now find out dot product of a bar dot b bar. How many terms it will be? How many terms there will be in a bar dot b bar? It is, look
6.
here, how we are multiplying. How many terms?
6 terms.
Ax into 6. See, I'll tell that. Ax into bx is 1. Ax into by, ax into bz, 3. Okay. Ay into bx, ay into by, az into bz, 3. 3 plus 3, 6. Az into bx, az into by, az into bz, 9. 6 plus 3, 9. Totally there will be 3 terms. It's just like your normal multiplication. Suppose if you are multiplying x1 plus y1 plus z1 into x2 plus y2 plus z2, how will you multiply? First you will multiply first term with first term of first equation with second term of second equation, first term of first equation with third term of second equation. Same way you are multiplying. Okay, that is, let us look what we'll get. A bar dot b bar is equal to ax bar plus ay bar plus az bar dot with bx ax bar plus by bar plus bz az bar. So students, here we'll be getting 9 terms. Out of these 9 terms, 6 terms will become 0. 6 terms will become 0. Let us see how it is. That is ax dot with bx, ax dot bx. This is ax dot ax. It is unit vector. It is the above equation only. Ax dot ax is 1. That will give us ax into bx. But if we dot ax with ay, that will be 0. That is our previous equation. Ax dot ay is 0. Similarly with the others, ay dot ax, or it may be x dot z or az dot ax, it is 0 only. That is ax dot ay will be 0. This ax dot ay, when we are multiplying ax bar with by ay bar, then ax bar with bz az bar, that is ax bar dot az bar, again it will be 0. Next, ay bar plus bx into bx ax bar, ay bar dot ax bar, again it is 0. Next, ay bar dot by ay bar dot ay bar, it is 1, the above equation, ay bar dot ay bar is equal to 1. Next, ay bar dot bz az bar, it will be 0 because ay bar dot az bar is 0. Similarly, az bar with, if you take with bx ax bar, the az bar dot x bar, it will be 0. Hence, there are 9 terms. Out of 9 terms, similarly, we will be getting 6 terms as 0. The only terms that remain are ax bx of ax bar dot ax bar plus ay by of ay bar dot ay bar plus az bz of az bar dot az bar. Hence, finally, the equation that we get is a bar dot b bar is equal to ax bar dot x bar is 1 plus ay by plus az bz. That is our equation 13. Okay. What are the applications of dot product? First application is, it is used to find the angle theta between the two vectors. Just we know that from definition itself, because a vector dot b vector is magnitude of a vector into magnitude of b vector into cosine of angle theta between the two vectors. Hence, we can find the angle theta between the two vectors. That is one application. Another application is, we can find the, if the two vectors given are p vector and a vector, unit vector, then we can find the component of p vector in the direction of unit vector a. This is as shown in the next figure. P vector, just we have also taken that concept, projection of p bar on a bar, that is p bar dot a bar is equal to p bar into a bar into cos theta. That is, a bar is unit vector, hence it is just p bar into cos theta. That is projection of p bar and q bar. Suppose we take two vectors, one is p bar, another one is q bar. Then this q bar or a q bar, that will be, we know the unit vector. How to find the unit vector? It is the given vector divided by its magnitude. The definition of the unit vector is, it is equal to the given vector divided by its magnitude. Hence, the projection of p bar on q bar can be expressed as p bar dot, this will be p bar dot, what is this aq bar? It is q bar divided by magnitude of q bar into cosine of angle theta. Here cos theta is missing, that just consider that. So it is p bar dot q bar divided by magnitude of q bar into cosine of angle theta. The third application of the dot product is, it is used to find the force. Suppose if you are exerting a force on an object, it displaces to some distance. Right? If you multiply, take the dot product of the force with the distance, that gives the work done. Because we know that work done is given by the product of force and the displacement. Is it not? That is, work done is force into displacement, F bar dot d bar. If the force varies continuously, suppose say for F1 the displacement is d1, for F2 the displacement is d2, for F3 force the displacement is d3. Therefore, then we have to take the integral of that. We have to take the integration. That is, W is equal to, work done is equal to F1 dot d1 plus F2 dot d2 plus F3 dot d3, like that. Hence, the total work done will be calculated by the integration, that is, W is equal to integral of F dot d or F dot dl, displacement, force into displacement. Consider two vectors, friends. A bar is equal to 2ax bar minus 5ay bar minus 4az bar, and b bar is equal to 3ax bar plus 5ay bar plus 2az bar. Take this example, friends, quickly. Note down this example. A bar is equal to 2ax bar minus 5ay bar minus 4az bar, and b bar is equal to 3ax bar plus 5ay bar plus 2az bar. We have to find the dot product and the angle between the two vectors. Find the dot product and the angle between the two vectors. Come on, do that. I hope you all are following here, students. Yes, students, are you following here? Okay, fine. First find the dot product and then find the angle between the two vectors from the definition. This is our definition. Dot product is given by a bar dot b bar is equal to ax bx plus ay by plus az bz. Just now we found out that. This one here. Here it is. A dot b bar is equal to ax bx plus ay by plus AZ BZ, the dot product of the given two vectors is the x component of A into x component of B plus y component of A into y component of B plus z component of A into z component of B. What is the component of x here? It is 2. Y component is -5. Note that it is -5. Don't take it as +5. Answer will be wrong. Then z component is -4. Z component is -4 of vector E. Similarly, x component of vector,
-11.
what is it -11? Answer A bar dot B bar. You are telling the answer. Yes. 1 minute. I will come to that. X component of B vector is 3. Y component of B is 5. And Z component of B is 2. Now let us multiply them. AX, BX. X component of A vector is 2. Then x component of B vector is 3. 2 into 3 plus y component of A vector is -5. And y component of B vector is BY is +5 plus Z component of A vector is -4 and Z component of B vector is 2. -4 into 2. Then it is 2 into 3 6. -5 into -5 is -25. Then plus into -4 into 2, that is -8. If we simplify this, 6 minus 25 minus 8, that will give us -27. Okay, it is -27. Students, note down here. This is the dot product. Yes. Next, find out the angle. How to find the angles between the two vectors? What is the formula? That is, it is given here. This is the formula to determine the angle between the two vectors. Theta is equal to cos inverse of A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Find out the angle here. If you want to find the angle, what we should calculate first? We should calculate the A bar, magnitude of A bar, magnitude of B bar. Magnitude of A bar is given by square root of, we know how to find the magnitude of the vector, 2 square plus -5 square plus -4 square. That will give us square root of 45. Similarly, find the magnitude of B vector. Magnitude of B vector is square root of 3 square plus 5 square plus 2 square. That will give us root 38. Therefore, theta is cos inverse of A vector dot B vector divided by magnitude of A vector into magnitude of B vector. That is cos inverse of, we already calculated A vector dot B vector, dot product. It is -27. -27 divided by magnitude of A vector is root 45. Then magnitude of B vector is root 38. That will give us 130.762 degrees. Okay, just calculate that. Cos inverse of -27 divided by square root of 45 into root 38. That will be how much? Just verify your answers. Cross verify, students, here.
Sir, 145.
145 you are getting. Okay, I'll just check that. Anybody getting different answer?
So 130.76.
Yes, correct. No, it is. Okay. Okay. I'll just verify once again. Somebody is getting some different answer. We'll see that. Okay. Anybody getting the same answer? 130.762. Okay. Let it. Fine. This is how we have to find the dot product of two vectors and the angle between the two vectors based on the formula whatever we are having. First, find A bar dot B bar. Then magnitude of A bar, magnitude of B bar, and theta will be cos inverse of A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Okay. In today's class, students, we have covered the topic on vector multiplication. Okay, vector multiplication, that is scalar product or the dot product. What is scalar product? What is the dot product? What it means? Okay. Then later on, we have also defined it in one more way as the projection of A vector on B vector. The same thing, A vector dot B vector is magnitude of A vector into magnitude of B vector into cosine of theta between the A vector and B vector. It is a scalar product. Hence, it is called a scalar product because the dot product is scalar in quantity. Then the different properties, that is A vector dot B vector is magnitude of A vector into magnitude of B vector. If the two vectors are parallel to each other, they are perpendicular to each other, then A vector dot B vector is 0. If it is a dot product of a bar dot b bar and b bar dot a bar. They are commutative in nature. Then they also are distributive. It is a bar dot of b bar plus c bar is equal to a bar dot b bar plus a bar dot c bar. Then dot product of vector with itself is magnitude of that vector square. Then if you are taking the dot product of x to y, y to z, or z to x, that will be 0 in Cartesian system, unit vector dot products. Then any vector dotted with itself is 1 in Cartesian system, the unit vectors. Then we have considered two vectors, we have taken their dot product, and we have arrived at the formula a bar dot b bar is equal to ax bx plus ay by plus az bz. Then we are finding out the formula using the we are finding the angle theta using the formula theta is equal to cos inverse of a vector dot b vector divided by magnitude of a vector into b vector. It is also used to find the projection and also to find the magnitude of the force component, that is the work done, that is given by force into displacement. These are the applications of the dot product. Then we have solved an example on how to find the dot product and the angle between the two vectors. Okay, in examination they may give this and they may ask to find the scalar product. Instead of giving it as dot product, they may ask it as find the scalar product and the angle between the two vectors. It is the same thing what we have done. Dot product or scalar product both mean one and the same. Okay, in the next class, students, I'll be explaining vector product or cross product of vectors. So what is vector product or cross product of vectors, and then we'll go on to the properties of cross product that we'll take up in the next class. Okay, hope you all have understood here, students.
Yes, sir.
Yes, sir. Yes, sir.
Any doubts here, students? Any difficulty in today's discussion? I hope everybody are clear with the properties of the dot product. Yes, Ankita? Ankita?
Yes, sir.
Clear with the properties of the dot product?
Yes, sir.
Okay. Harshigowda? Harshigowda?
What is the question for first IS, sir?
I'll discuss that. I'll discuss with sir and I will let you know, please. Okay?
Okay, sir.
I'll discuss with sir. Fine. Vijay? 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 Vishal Bhosle? Vishal? Vishal? Sanket? Sanket?
Yes, sir. Understood.
Understood? Good. Sanket? Sanket?
Yes, sir. Understood, sir.
Understood? Fine. Okay. Then we'll continue in the next class. Thank you.